And the book, their little title for this section is Division Algorithm. And since you guys we've talked about algorithm before, so that should not frighten, scare, or make you upset in any way. Get there. Division. The algorithm, and if you remember what the word algorithm means the way that you do it when you do long division, or we call it long division, which always makes everybody happy. We follow this little pattern, this little algorithm. It is you divide, you multiply, you subtract, and you bring down. Those are the 4 steps in pretty much any division problem. When it's real simple division, you just do the division and it's over. But if there are more numbers than that, you have to follow that little pattern. I'm sure you're well schooled in it, so let's look at an example of that. Here is, for example, an example, 3 into $852. 3 into $852. Now it is imperative, it is important, it is very, 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 another word for important? I don't know. Mrs. Smiley, another word for important.
Essential.
Essential.
Mandatory.
Mandatory, that's probably good.
Essential.
Essential is great. I can't come up with anything better than that. You will know that on your homework paper there are those little squares. This is the point where you need to definitely use those little squares, because if you're not lining up numbers, you're going to get lost in the whole algorithm and something's going to go wrong. I have been known to make children redo complete assignments if they don't put their numbers on at least the lines. You don't have to make them go in each and every little box, but it would be helpful for you. It really works well. All right, so here's the pattern that we follow. Okay, you look at your outside number here is a 3. And you look at the first number. Does 3 go into 8? It does. If it's smaller than that, you can divide it into it. And then 8 divided by 3, how many times does 3 go into 8? Or you could say 3 times what number gives you is close to 8 without going over. Andrew would say 2. So you put your little 2 up there, because we're pretty sure that that's my division. Then you go to the multiplication thing, which means you multiply the number, those 2 numbers together that you said 3 went into. That's your multiplying. You get 6, and you write it underneath the V8. And then you get to your subtracting thing. 8 minus 6 is 2. Right, and then we do our bring down. And I desperately, very much, it's essential, it's imperative, it is whatever, that you, when you bring down a number, I want you to draw this little arrow here to show me that you are bringing down a number. And then once you get to the end of the algorithm, guess what? It starts all over again, except now you use 25 as the number that you're dividing 3 into. So starting from the very get-go again, how many times does 3 go into 25? Jordan Shaw? 8 times. You write the number above the 5, keep those straight there. 8 times 3, my multiplication is 24. I subtract. I get 1, which is good. Remember, you can never have a number bigger down here than your divisor was. And then my really long arrow here, I get a 2. And the whole thing starts all over again for the 3rd time. I don't know. Let's go pink. Why not? And then how many times will 3 go into 12? Victoria?
4.
4 times. 4 times 3 is 12. Subtract. Nothing left over, no remainders, no nothing. The one problem I have with this is what though? This was $852, so your answer should also be in dollars. And much of this is only as easy as well as you know your multiplication tables. Because if you don't know your multiplication, you really don't know your division tables, and if you don't know your division tables, this is going to take you a long time, and there's going to be opportunities for you to make lots of mistakes. Okay, so please again, make sure you show me those arrows. You know, you'll know you're done with the division problem because there'll be no numbers left over here that don't already have an arrow underneath of them. So you're mesmerized, you're excited, you're good to go. Here is another example problem. 5n equals, what is that? Well, 365. Which means 3 times what number is 365? Or 5 times what number? 5 times what number is 365? Now who can tell me what, before we do this problem, what is the next thing you should do? Let's see if you're, Maggie?
Divide.
Nope. We will divide, but that's not the next thing you should do. You're kind of skipping a step that I say you really need to do because I see so many people miss these on assignments that even though you think you know what you do, maybe sometimes you're right, sometimes you're wrong, but you just desperately need to do this, and it would be what, Frankie?
Write it down.
No, I already wrote it down. Sir, I've already got it down there, Frankie. Look, it's there. Frankie?
Think of an easier problem.
Yeah, think of an easy multiplication problem. To know whether you multiply or divide, you know, whether it be 2 times 3 is 6. If you didn't know that this middle one was a 3, what do you do with those two to get 3? You divide them out. So then there you go. Now comes our division. 365 divided by 5. Here we go. The algorithm we're going to use again is divide, multiply, subtract, bring down. Please understand this. 5 doesn't go into 3, so you should not put a number above the 3. We don't put 0 in front of numbers, so you don't really have to put that X there, but I'm going to do it just to make sure. Then I go to the next one. 5 times what is close but not over 36? Trevor?
7.
Yep, 5 times 7 is 35. That's my multiplication. I subtract. I bring down. Nice pretty little arrow there. Maybe I can decorate it. Put tinsel on it. I don't know. It is getting close to pumpkin. And then 15 divided by 5 would be 3.
3.
Nothing left over, no remainders. My answer is 73. 73. And then they are going, well, let's do one more, sorry. 7 into 365. I'll let you do this one. 365 divided by 7. 365 divided by 7. And Jacob Bauman says the answer to that is
52 remainder 1.
Now let's check and see. 7 didn't go into 3, so you shouldn't have a number above the 3. But 7 does go into 36 5 times. That's 35. I subtract. I bring down. How many times does 7 go into 15? I think you said 2, right? Jacob, you get 14. You subtract. Now here's where you stop. Because there's no number left to bring down, I have my little arrow already under the 5. Yes, this in fact is the remainder of 1. Now the book is also going to ask you, how do you check to make sure that you got this problem right? What is your check to figure out if you got that problem right? Addison?
You do 52 times 7.
And then what would you have to do?
Add 1.
Right. You have to take your quotient, multiply it by the divisor, And then if you had a remainder, you have to add that one back onto it. And when you should get the same answer for both. I think you're pretty much good to go on that, I'm sure. Mrs. Lutz